Hi, I'm Colin Williams at the Global Derivatives 2016 conference, and I'm here with Valery Kholodnyi of Verbund. So Valery, thank you very much for joining us. Can you tell us a little bit about your work on non-Markovian modeling of commodity markets?
Thank you so very much for your kind introduction. It's a great pleasure for me to be here at the Global Derivatives this year as well. Absolutely. So what we have in commodities market in general and in power markets in particular, very special behavior of the prices, where the prices could stay in a general range. Let's say in US the range is like about $30, and then once in a while the prices could go up, to as much as $7,800, and in a couple of days they would go back, as nothing would happen. That's what you had maybe like 15 years ago. Since then, the prices not only could go upwards, but they could go downwards and then would come back up, like nothing would happen. And the spikes, that's the name for these events, are not just short-term and rare anymore. So the prices that we need to model have this very special behavior, and my model that I called 18 years ago non-Markovian approach can really do the job. On top of this, in power markets, we also have negative prices. This is basically due to the non-stability of the power, or practical non-stability. And that is why when basically you have a lot of supply or not as much demand, in order to balance the grid, the prices go negative. So in addition to describing the positive prices, the model should describe negative prices as well in the same consistent fashion. And that's what my model does. For example, for downward prices, the prices can go not only towards zero, but they could bypass zero and become negative. And this is becoming one of the standard approach and working forces for the energy markets and commodity markets.
That's very interesting. So, so why do you think it's necessary to have forward-looking market-implied risk-neutral probabilities from forward curves?
Because of the fact that commodities markets, again in general, and power markets in particular, they change drastically because of various regulatory regimes, and just because the markets are different based on different technologies that you use to generate, for example, power. You really don't have too much faith in the historical data. Right. So you have to rely on something that is coming from the future. Right. And what is coming from the future? What is this information? Essentially what we have in commodity markets or power market or energy markets is a forward curve. It's not a curve, it's chunks of various swaps of different duration delivery time. And you have to extract the silver bullet, the underlying forward-looking market-implied risk-neutral process just from this forward curve. No options, because the option market is highly liquid there. And it turns out that this model, non-Markovian approach, allows for us to extract this information overnight using various architecture like GPU, and basically in the morning start with the analysis of
That's very exciting. So do you think you can apply this non-Markovian approach to look at the intraday power prices?
Absolutely, and essentially those prices is exactly what we model from the so-called observable day-ahead prices, which are not the spots but are day-ahead swaps or forward prices that expire all the hours for tomorrow based on the closing today, for example, at 12 p.m. And if you can extract this information, and that's what we do, extract, then, for example, you can price the most sophisticated products nowadays in the market that helps you to mitigate the price risk of spikes, German week futures. And they are exactly based on this intraday hourly power processes.
Very interesting. So would you be able to use this non-Markovian modeling approach to look at American options?
Absolutely, and the way I do it, which is especially important for oil markets, I use my result that go back to 95, I showed that American options or American contingent claims in general, they do in fact satisfy a semi-linear evolution equations, where the nonlinear terms plays the role of the cash flows that should be received in the exercise region to compensate the holder for foregoing the exercise. And you have a lot of standard tools to solve semi-linear evolutionary equations. And that's exactly what we are using to handle long-term American style, for example, swaptions in the oil market, which are rather very sophisticated instruments, but they are standard, for example, in NYMEX market.
Fantastic. That's really great, Valery. Appreciate your time. That was one of the most interesting things I've heard today.
So thank you so very much. I appreciate your time.